Increasing, decreasing, and relative extrema. Charting the first derivative. The function we will consider is f of x equals x squared over x minus 1. We note that the function is undefined when x equals 1. So x equals 1 is not in the domain of the function. We begin by calculating the derivative of f of x, and we use the quotient rule. So f prime of x is the denominator, x minus 1, times the derivative of the numerator, 2x, minus the numerator, x squared, times the derivative of the denominator, 1, over the denominator, x minus 1 squared. We simplify the numerator, and it looks like x squared minus 2x. And then finally, we factor the numerator, and we end up with x times x minus 2 over x minus 1 squared. From here, we can read off the critical points, and they occur when x equals 0 and when x equals 2. These are places where the derivative is 0. The derivative does not exist at x equals 1, but notice that the function is not defined at x equals 1, so this is not a critical point. Now we chart the derivative, and the first thing we do is write down the three important x values, 0, 1, and 2. 0 and 2 are critical points. 1 is a place where the first derivative doesn't exist, and in fact the function does not exist. So to indicate that the function does not exist, we will draw a vertical line at x equals 1. And when we draw anything resembling the graph of the function, we will not cross this line. The next thing to do is to look at what's happening to the function in various intervals. When x is less than 0, f prime of x looks like x times x minus 2 over x minus 1 squared. X is less than 0, x minus 2 is less than 0, and x minus 1 is less than 0. So we have minus times minus over minus squared, and that's plus. So in this interval, f prime of x is positive. As a result, we indicate that by putting pluses on our chart when x is less than 0. Now we move to the next interval, which is when x is between 0 and 1. In this case, x is positive, x minus 2 is negative, and x minus 1 squared is a negative squared. So we have negative times positive over negative squared, which is negative. And we go to our chart and we put minus signs between 0 and 1. Now we move to the next interval between 1 and 2, and we do exactly the same thing. And this time, x is positive, x minus 2 is negative, x minus 1 is positive. So we've got positive times negative over positive squared, which is negative. We go to our chart and put in minus signs. And the last interval is when x is bigger than 2, and now x, x minus 2, and x minus 1 are all positive, so we have positive, positive over positive squared, which is positive, and we put pluses on our chart. Now what we do is use the information on the chart to sketch the basic shape of the graph, and we do this by drawing lines that slope upward, where f prime is positive, and drawing lines that slope downward, where f prime of x is negative. And it's important not to cross the line x equals 1, where the function does not exist. So what we end up doing then is sketching something that goes up between minus infinity and 0, down between 0 and 1, down between 1 and 2, and up between 2 and infinity. The next thing to do is try and figure out from here where the function is increasing and decreasing. f of x is increasing where the lines go up, and you can see that's between minus infinity and 0, and between 2 and infinity, which is where f of x is increasing. We look to see where the lines go down. That's between 0 and 1, and 1 and 2. So f of x is decreasing on 0, 1, union 1, 2. Notice that it is incorrect to say that the function is decreasing between 0 and 2 because the function is not defined at 1. So you have to break the interval so that we're only talking about places where the function is defined. Okay, now what we want to know is what sort of extrema have we got? So we look at x equals 0, and we can see that we go up to the left and down to the right, which makes it a local maximum. And then we look at x equals 2, and we see that we go down from the left and up from the right, which makes it a local minimum.